Section 7.1 is about polar coordinates. That's going to give us an alternative way of describing points in a two-dimensional plane. We're used to thinking of that as the xy plane and using rectangular coordinates. So we describe a point as an ordered pair of values, an x value and then a y value. So that, for example, if I wanted to plot the point 2, 3, I would start at the origin, which is where the x and y axis meet, over 2, up 3. So that gives me the point 2, 3, and you'll notice that's an x value followed by a y value. Okay, well, in polar coordinates, we're also going to be describing locations on a plane. We're just going to be describing them with different pieces of information. It's still going to be a pair of numbers, but they're going to give me different information because I'm going to have a different frame of reference. I'm going to have a special point, which will be the pole. Okay? And r, which is one of my polar coordinates, is going to represent the signed distance from the pole. Now, we're going to have to talk about what signed distance means. Distance, you kind of understand. Signed distance, we're going to have to talk about. But essentially, we're going to have a positive direction. And so if r is negative, it's saying go that distance, but in the opposite direction. Okay. And then I'm also going to have a ray. Now, a ray is just half of a line. So it indicates a specific direction. And we call that the polar axis. Okay. And theta is going to be the angle that we rotate from the polar axis. And what that's going to do is that's going to determine the positive direction. So what does this actually look like? Well, let's say I wanted to plot a point r theta equals 1 pi over 4. In polar coordinates, we give the r value first and then the theta value. Just like in rectangular coordinates, we always give the x value first and then the y value. So it's an ordered pair. Okay? I'm writing r theta just because that's new. Totally fine for me to just write 1 pi over 4, and we'll be expected to eventually know that's the r value, that's the theta value. Okay. Now, in plotting a point, I usually actually start with the theta value. So I would say, okay, I need to, from my polar axis, rotate pi over 4. So this ray that I've just drawn now determines the positive direction. Okay. Now, if I extend in the opposite direction, which I'm going to just do as a dotted line, that would determine the negative direction. Okay, at least when theta is pi over 4. Now I look at r. Here r is positive, so I want to go a distance of 1 in the positive direction. So I would come 1 unit out. So I'm saying this distance right here is 1, and this would be the point 1 comma pi over 4. Okay. All right, excellent. Now, certainly I know what it means for an angle to be negative. That would just mean that I'd be rotating in the clockwise direction instead of in the counterclockwise direction. Let's try plotting a point where the r value is negative. So I'll erase this point, so we're back to just our frame of reference. Okay. Let's try plotting -2, 3 pi over 2. So my r value is -2. My theta value is 3 pi over 2. Okay. So I'm going to first of all draw the ray determined by my theta value. So starting on the polar axis, we're going to rotate 3 pi over 2. So this ray determines the positive direction. Notice this feels a little bit weird because now the positive direction is down. The positive direction isn't set. The positive direction is always determined by what the angle is. Okay. And the negative direction is just the opposite direction. So when my R value is -2, the absolute value of that is 2. That's going to be the distance that we're going to go, but we're going to go in the negative direction. So not following the ray, but following the extension of the ray in the opposite direction. We would come up to like so, and we would be at the point now, -2, 3 pi over 2. Now, one thing that I think is kind of interesting here is that there are other ways that I could describe that point in polar coordinates. In rectangular coordinates, the coordinates for a point are unique. If I change the 2 or the 3, I'm at a different location. But let's just take a look at this point, 2, pi over 2. So if I were to plot the ray corresponding to pi over 2, I'm going to do that in blue, that points straight up. Now, for this point, up is the positive direction. My R value is positive, so I want to go in the positive direction, and I want to go 2 units. So I would come, oh my goodness, that's the same point. So polar coordinates for a point are not unique. Any point on the plane is actually going to have infinitely many names in polar coordinates. The R value is only semi-unique. For this point, the distance to the pole is 2, if I just measure it as an actual positive distance. So if I determine that the positive direction is up, my R value must be 2. If I determine that up is the negative direction, my R value would be -2. But for this point, R could only be plus or minus 2. But theta has infinitely many options, because any angle that's coterminal with pi over 2 would also determine that up is the positive direction. And any angle that's coterminal with 3 pi over 2 would also determine that down is the positive direction, so that up is the negative direction. Okay. So points no longer have unique names when we're working in polar coordinates. It's kind of neat. Okay. So we're going to practice just plotting some points and coming up with additional names for points. But before we move on to do that, I want to introduce a slightly different way of drawing my frame of reference. Here, I've got rectangular coordinates here and polar coordinates here, but they're both describing points on the plane. So generally what we'll do, so that we can reap the benefits of both systems, is we're going to work with overlapping coordinate systems. So if I draw my x and y axis for rectangular coordinates, I can overlap my polar coordinates on here. So the pole, that's supposed to be a special point, okay? Well, the special point I have here seems to be the origin, so it kind of makes sense to put the pole at the origin, okay? And then the polar axis, that's supposed to be a ray that's determining the direction that I'm going to count as 0. Well, it kind of makes sense to put the polar axis on the positive x-axis. If I do that, we're used to measuring that this angle is 0. We usually measure our angles when we're working with angles in trig functions. We usually measure from the positive x-axis. This is 0, this is pi over 2, this is pi. So by putting the polar axis on the positive x-axis, we're preserving what we're already used to. Okay. So as we move forward, I'm going to be using this overlapping frame of reference. Okay. And eventually we'll be going back and forth between the two systems. So I think it's nice to just get used to having that frame of reference overlap. All right, we'll keep going and practice with some more points in the next video.